Alright, in the second part, we will construct the circuit in figure 3. Alright, we need a 2.7 K resistor. That's the 2.71. We will connect 2.7K and 5.6K in series. Now let's do that. This is the 5.6. Let's connect it here. All right, and 2.7 will be in series here. Okay, now in this circuit we have one DC and one AC supply. Let's connect the DC supply first. It should be 1.5 volts. DC supply is here, the V plus port in analog discovery, the fourth from the left. Right, I'm connecting it. Here, because the supply is here before the 5.6K. And I'm connecting the AC supply, the function generator, before 2.7K. So it's the W1 channel, W for waveform. And we are connecting it here. All right, that's pretty much the circuit. Now I want you to note one thing. The ground is here in the circuit, right? Now we should put the ground to an unrelated row. And we will use this ground when we are taking measurements. All right, so let's go to waveforms. Our positive supply is on with 1.5 volts. That's done. Now we need an AC voltage. Remember from last week, for AC voltage, we go to waveGAN. All right, it asks an 4-volt amplitude, which is ready, a sine wave of 100 Hertz. And this is our AC wave, our waveform. We are running this too. All right. Now our circuit is up and running. Now we need to compute separate sums for the measured DC and AC components. Now let's do that. Of course, we are using scope to take measurements. All right, we are connecting our channel. Let's take the measurement on the AC supply first. I'm putting the positive node of channel 1 here and the negative node on the ground. All right, so that's our measurement. It's as expected, a peak voltage, a peak-to-peak voltage of 8 volts. Let's also see it numerically. Yeah, it's 3.99 to minus 4.01. So it is an 8-volt peak-to-peak supply. Right. Now, what's the DC component in the AC supply? Now, it's expected to be zero. That's a theoretical value, right? We can see the DC voltage by turning the wave generator off. It's like almost zero. It's around 0.0 minus 0.01. Let's record it as such. All right. Secondly, let's measure the power supply. Turn the wave generator back on. Go back to our circuit. Now the negative node stays on the ground. But wait. We will take the positive node of our channel and connect it in parallel with the DC supply. Now let's see our measurements. All right. It is around 1.49, which is the supplied DC voltage, right? Almost. And what's the AC component? Zero, right? We don't have any periodic signals. All right. Now we measured AC and DC components on the AC and DC supplies, and as expected, the AC supply has a peak-to-peak AC value of 8 volts and almost zero DC voltage, and the DC supply has almost 1.5 volts of voltage, which is the supplied voltage, and zero AC voltage. Now let's measure the DC and AC components on 2.7 kilo ohms and 5.6 kilo ohm resistors. All right, actually this can stay here. Now I'm taking the negative node of my channel and plugging it in here. Now please note that the channel is now connecting the voltage across the 5.6K resistor. Right, as you can see, we have an AC voltage with a DC offset, right? Let's turn off the DC offset. And this is our AC voltage across the 5.6 resistor. Now its peak-to-peak voltage is around, let's see, 2.69. To minus 2.7, which is around 5.39 volts. Let's write it as such. Right, let's calculate the DC offset. Let's turn off the AC voltage and turn on the DC voltage. It's around 1, almost 1.01 volt. Right, let's go back to our circuit. Now we will measure the voltage across the 2.7K resistor. We're gonna put our channel nodes here and here so that they will measure the voltage across this resistor. Let's go back to our waveforms. All right, before doing anything else, we can see the DC voltage because our DC is on and AC is off. It is around 0.48. Right, let's see the peak-to-peak AC voltage. It is around it's 1.3 to minus 1.31 maybe, so let's record it as 2.62 volts. All right. Right. So these are the measurements for the second part of this week's lab. Now you can calculate the theoretical measurements and answer the questions regarding the Kirchhoff's voltage law using your theoretical values and the measurements that we just got.